Which of the following below give a representation of the vector in component form in which the x component is 2 and the y component is -3? Let's begin with a review. A vector with initial point P and terminal point Q can be expressed as the vector PQ, which can also be expressed using a lowercase letter, in this case vector v. When the vector PQ is expressed in component form, the x component is x sub 2 minus x sub 1, and the y component is y sub 2 minus y sub 1. And if we let a equal x sub 2 minus x sub 1 and b equal y sub 2 minus y sub 1, we can say vector PQ in component form has an x component of a and a y component of b. When a vector is expressed in component form, the vector is in standard position, which indicates the initial point is at the origin and the terminal point is the point a comma b. We can also express a vector using the unit vectors I and j, where the I vector is a unit vector with an x component of 1 and a y component of 0. The j vector is a unit vector with an x component of 0 and a y component of 1. So if we have vector v in component form, where the x component is a and the y component is b, we can express vector v as a times vector I plus b times vector j. And the magnitude or length of the vector v equals the square root of the sum of a squared and b squared. To begin, let's let the given vector be vector v sub 1, in which the x component is 2 and the y component is -3, which means using the unit vectors I and j, we can express vector v sub 1 as 2 times vector I minus 3 times vector j. If we take a look at the last two options below, we have -3 times vector I plus 2 times vector j, which is not the given vector. However, 2 times vector I minus 3 times vector j is a representation for the given vector, and therefore we check this box. And now let's take a look at the graphs of the vectors. Because vector v sub 1 is in component form, the graph of vector v sub 1 in standard position would have the initial point at the origin and the terminal point at the point 2 comma -3. Looking at the 5 graphs, there's only one vector with the initial point at the origin, which is the second vector here. The initial point is 0 comma 0, and notice the terminal point is 2 comma -3, which indicates this is a representation for vector v sub 1. Vector v sub 1 has an x component of 2 and a y component of -3. So let's go ahead and check this box. Now that we know the graph of the given vector, any other vector that points in the same direction and has the same length or magnitude would also be a representation for the same vector. So this first vector appears to be pointing in the same direction, but it does not have the same magnitude or length. Therefore, it's not a representation for the given vector. This last vector in the first row is pointing in the opposite direction. Even though it does appear to have the same magnitude or length, it would not be a representation for the given vector. And just to show this, let's find the component form of this vector. Notice the initial point is 2 comma -3, and the terminal point is the origin 0 comma 0. So let's call this vector v sub 2. The x component is 0 minus 2 or -2, and the y component is 0 minus -3, which is +3. This vector does have the same magnitude, but it points in the opposite direction. This vector is the opposite vector to the given vector. Now looking at the second row, again this first vector is pointing in the opposite direction. Even though it does appear to have the same magnitude or length, it would not be a representation for the given vector. It's actually the same vector as vector v sub 2. You may want to find the component form of this vector just to verify. And now looking at the graph of the last vector, notice the vector is pointing in the same direction as vector v sub 1, and it appears to have the same length or magnitude, and therefore this is also a representation for the given vector. And again, just to verify this, let's find the component form of this vector. The initial point is -2 comma 4. The terminal point is 0 comma 1. And notice the x component is 0 minus -2, which is +2, and the y component is 1 minus 4, which is -3. This is a representation of the given vector. I hope you found this helpful.